Hello, another short little video this time as a supplement to my video on the data model, showing the data model that I created a little while ago. One thing I'm loving about this whole process is how I'm engaging with all sorts of different people about things I'm finding, studies I'm reading, data I'm finding, data I'm analyzing. And I'm loving the engagement. I'm loving the sort of discussion over various points. And this video has been prompted by one of those discussions. I'm going to thank Elaine for sending me the email that she did. And she called me up on something, and quite rightly to do so. And so I want to address that in this video. And it's a general principle about data modeling and how to interpret data modeling. And I think it's a useful insight, not just when you go back and look at my YouTube clip of my data model, but when you see other people's as well. So I thought it might be worthy of making this little video here. So I've got some slides as ever to help me with that. So let me go to those slides so I can share them with you. Let's get it going as a little slideshow. So those who have looked at that YouTube video, and this will make more sense if you have actually looked at that previous video. But what I did, I looked at the case rate, or rather new case data for 6 countries, and I created an average curve for those 6 countries, but then in particular what I was doing was looking at the shapes of those curves for those 6 countries. And you may remember what I did. I took France, Italy, Germany, Norway, Spain, and Switzerland. I chose those 6 countries because they've had quite different approaches to managing the pandemic within their countries. And I looked principally at the peak of their new case load. So the day that in each of those countries they got the most new cases. And I aligned those curves according to that peak day, and then made the observation that actually for the 6 countries, there was very little difference between when they started to get a significant upturn in cases relative to the number of days later that they had the peak in those curves. And because they'd taken different strategies, adopted different strategies, and it was, to give it its time, I posited a hypothesis that, well, maybe the measures make little difference to that particular shape or that particular feature of those curves. What you must remember is that I was looking at one particular aspect of those curves. So because I normalized the vertical axis, I condensed every country's curves on a vertical axis from 0 to 1. What I wasn't saying is, or I wasn't commenting on where the peak has occurred, or not the peak numbers in those countries. That's something I normalized and is not something I was looking at in the analysis. It was primarily this time span between when cases started to increase in those countries and how many days later they got the peaks in those curves. So that was what I was looking at, and that was the feature of those curves that I was examining in that data model. So what I've been called up on is that I posited one hypothesis when actually perhaps the data might be suggesting other hypotheses as well. So let me just take you through the reasoning behind that and how that fits in. But do remember, this is applicable to any data model in terms of an approach and analyzing what we do. So let me, because of this was the purpose of my analysis, let me actually talk about what I was looking at. I was actually looking at 6 countries which adopted different strategies with regard, did they close schools? Did they close shops? Did they have lockdown? Did they encourage people to wash hands? All these are sort of different strategies with regard how you manage a pandemic. Now, pretty much all the countries did do those things, but the key thing was, in most of the countries, or if you compare the countries, when they took those actions was different relative to when their pandemic started. So if I have just calling this or using a notation that tries to convey this, if we say each of the countries have a series of possible actions they could take, and I'm going to call those the X's, and they took decisions when to implement each of those X's, and I'll call those time dates or those time points the Y's. So each of the X's has a Y, each of the actions has a time when it was implemented. And although it's probably a lesser order effect on the model, each of those countries probably had a different way of enforcing those things, or perhaps, which I'm going to call Z. And it's possible actually that rather than thinking about enforcement, maybe the Z is the compliance, how much the populations, or to what extent the populations of those countries complied with each of those X's that were implemented and when they were implemented. Now, the reason I've done that is that I can then use a notation to say, let's say for Italy, which was one of my 6 countries, they've got a set of these variables: the X of Italy, the Y of Italy, and the Z of Italy. And what that means in words rather than symbols is that Italy took decisions about what measures to take, the X's, when to take them, the Y's, and how they implemented them. And the Italian people responded, in a sense, how they complied with those things. So there's a subset of all of those possible variables that Italy actually implemented. And the other 5 countries, Spain, France, Norway, Switzerland, and Germany, did their own combination of their X's, Y's, and Z's. So just trying to create like a shorthand, we've got 6 unique combinations of X, Y, and Z implemented in each of my 6 model countries. And I chose 6 countries where I believe those decision spaces are different. There are differences in those combinations of decisions that they've made. And yet, with those 6 different combinations, we arrived at the same characteristic that I was looking at, i.e. the average time interval, or the modal median time interval between when the curve started in those countries and when they reach peak. What I wasn't looking at, for example, I'd mentioned to you before, because I normalized the vertical axis, is what those peak numbers were. And it may well be that those 6 decision spaces of the X, Y's, and Z did make a difference to where the peaks were on the vertical axis, but I couldn't determine that from my model because I'd normalized the data on a scale of 0 to 1 for each of those countries. And what you might remember in the video I talked about Trumpland and Bongo Land, because I normalized the data, I took out that difference. You couldn't tell if any of these countries were Trumplands or Bongo Lands. It's about the horizontal axis comparison that was the thing that I was saying. And so the thing I was coming to the point of was, well, there's 6 different sets of decisions that have been made in those 6 different countries, and yet the feature I was looking at was the same. And so effectively what I appealed to was this idea, well, rather than maybe it's down to the X, Y's, and Z's, are there instead, or is there instead, another factor, which could be one of the X's, one of the Y's, and one of the Z's, and I'll come to that. But was there a single factor, or certainly a smaller number of factors, which you could measure in Italy, Spain, France, Norway, Switzerland, Germany, which here I've called factor alpha, that actually, because it was much more similar in the 6 countries, that is why we got the same characteristic in the curves that I was looking at. So I'm looking at factor alpha, or maybe a small number of factors, factor alpha and factor beta, for those 6 countries. And it just so happened that they were very similar. And so what we've got here, and I've lost a bit of text there, let's see if that appears. Okay, so what I was hypothesizing was that, well, is there some other factor which is more similar or the same for the 6 countries? And that's why the curves were the same. And effectively what I was doing there was appealing to something called Occam's razor. Now, Occam's razor is a philosophical concept that basically says when you're looking at competing hypotheses to explain a phenomenon, the hypotheses that require the fewest assumptions are usually, and are more often, the best hypotheses. So if you've got a hypothesis that relies on 10 independent assumptions and you've got a hypothesis that relies on 2, it's very likely the one that relies on 2 is going to be more robust to closer examination. And that's what I was doing here. Essentially, what I was comparing was, we've got a hypothesis that measures taken by those countries, different measures taken at different times in different ways, somehow came together to give the same curve. So effectively, Italy's combination of X, Y, and Z just happened to be so well chosen that it worked for Italy in the same way that the X, Y, and Z for Spain, although they were different, were chosen, but they were so suitable for Spain in the same way as then the X, Y, and Z for France were taken or chosen. And that happened to be the best way for France. And that was true for all 6 of those countries. So we're having to get that same feature of the curve, we're having to make all those assumptions, versus actually, isn't there maybe just one factor that's true of all those 6 countries, which is more similar? And that's why the curves were the same. So I was appealing to Occam's razor. And what I did, and this is the bit I was called up for, is I just gave one hypothesis for that. Was factor alpha the virus? So I made the statement, and I made it as a hypothesis. I said, well, maybe this means the virus is the thing that's determining that feature of the curves rather than our intervention. But of course, that's one hypothesis. There are other hypotheses which still appeal to Occam's razor. They are still one or a small number of factors. So for example, demographic. Was it possible that those 6 countries I chose, they had some feature in common or sufficiently similar between those 6 countries that actually is a strong determinant to the characteristic of the curve that I was looking at? So could it be, for example, the percentage of the population that's obese, or the percentage of the population that are of ethnic minority? Because again, I've seen a study today saying that they are more prone in the UK to get severe COVID outcomes. So was there some other factor, such as the demographic, or the weather? Is the weather a factor in that determining that particular characteristic of the curve that I'm looking at? So there's a whole host of possible single or small number factors that could be similar in those 6 countries. I mentioned virus in the original video, but it could be demographic. And there's an interesting musing here, which I've looked at. And this is this idea that I talked about X, Y, and Zs for Italy and X, Y, and Zs for Spain and so on for the 6 countries. And that's the full suite of all the decisions they made. So closing pubs, closing shops, banning gatherings, locking down the population, and so on. But is it possible that of all those X, Ys, and Zs, maybe 1 or 2 of them are the critical ones that make the difference to the characteristic of the curve that I was looking at? And actually anything else you do over and above that makes no difference to that characteristic of the curve. So could it be, for example, is hand washing the thing that determines that sort of time interval between when the cases start to increase and when the peak is reached? Everything else you do over and above that makes little difference to that characteristic of the curve. And the reason why that appeals to me is that hand washing, for example, was something that was highlighted, I think, for everyone, all countries at about the same time. So it's a very similar X, Y, and Z. So time frame of implementation, how it was implemented for all the countries. So maybe that was the thing that determines the shape of the curve, rather than whether you then ban gatherings above 2 people, 5 people, 10 people, 15 people, when you do that relative to when the cases started, whether you lock down. So all the other measures make little impact once you've done that first thing of, say, for example, hand washing. So it might not be hand washing, but that's the example I've chosen. So what I was called to order, and it was absolutely right to do that, was at the end of the video, I muted one hypothesis. What I didn't explore was there are equally other hypotheses, but the basis of all of those is that those other hypotheses, according to Occam's razor, need to be simpler to be viable, to my view, in the sense that the fact that the virus was the same or similar, assuming the virus may have mutated a little bit, the virus was certainly similar, so that might be a common factor. The demographics might be very similar in those 6 countries. Maybe that determines the shape of the curve. Or maybe it was something to do with X, Y, and Z. It's just that it's not the full suite of X, Y, and Z that makes the difference. It could be just 1 or 2 of them, and that was more similar between the 6 countries, and so that was the thing that made the difference. So there we go. That was my, or rather the spirit of my thoughts on that previous video, that yes, I just at the very end of it, and I probably do need to be more careful just to make sure I don't just throw one hypothesis, because the problem with that is that then people, if they engaged with my description through the data model and got quite convinced by it, and then I only present one hypothesis, that one hypothesis gets sort of perhaps undue weight in terms of how robust it is as an explanation. And then on social media, that then becomes something that's used for confirmation bias. It may well be the answer, but I've got nothing in my analysis to say the viral explanation is stronger than the demographic explanation, or that's no or less stronger than the washing hands explanation. So that was just the point I wanted to make there. So hopefully that made sense. I shall post this up and let people have a look at that and give me your thoughts. Share and subscribe to my page, and I can put more of these thoughts and wisdoms on that page. Thank you.